Question number 39. Question number 39 says most acidic, most acidic proton in the given molecule is. Now for most acidic, we need the hydrogen which is attached to most electronegative atom. So here it is carbon, here it is carbon. Yes, it is carbon and resonating, right? But here it is oxygen and resonating. So definitely the answer will be HB, and thereby answer is this one, B. Okay, correct answer for question number 39 is B. I am having a hard copy also in my hand just to confirm the answers if all good or some changes. So this is B. I hope this is clear. Here we have looked for the most acidic hydrogen. For that we checked the hydrogen which is connected to most electronegative atom. Question number 40. Which species has the ability to quantitatively, completely remove the proton HA from this particular molecule whose pK is given to be 22 in the given below? Okay, so now if I talk of pKa 22, as we have discussed that we have to compare relative products found. Like if I go this HaOH minus, so it is H2O, and one has an RC triple bond C minus. So if I compare the conjugate basicity, this is a stronger base, this is a stronger, weaker acid, right? This is relatively a stronger acid, and this is weaker base. So equilibrium will go backward. So this cannot form the anion or abstract this HA. Let us go to conjugate base of ammonia, which is NH2 minus. So this is our answer because NaNH2 will be a sufficiently strong base to abstract this acidic H. Okay, because if we talk of acid strength, then ammonia is a weaker acid than terminal alkyne. Thus, as a base, NH2 minus will be a stronger base than RC triple bond C minus. Right? So answer is B. Question number 41. If you just check the NCERT, the correct order of the dipole moment among the following is. This is directly from NCERT tables. Okay, and the answer, chloromethane has higher dipole than fluoromethane. Considering this much, if you know, then A and B to answers in A, not possible. Okay, first choice chloromethane has to be having more dipole moment than fluoromethane, and then comes the methanol and dimethyl ether. Between methanol and dimethyl ether, dipole moment of methanol is greater. So answer is C. Okay, if you have any doubt in between, please raise your hand. Coming to question number 42, choose the options where atom labeled as P is more basic than Q. Okay, we have to find where P is more basic. Now see, here it is a localized lone pair, whereas this P lone pair is a delocalized lone pair. Localized lone pair. So this is more basic. Whereas we have to search where P is more basic. So this cannot be answer. If same way I start checking here. Okay. So this is my sp3 donor. This is my sp2 donor. Okay, so sp3 donor will be better than sp2 donor. B also gone. Coming to C, amides are better base than from oxygen. That is correct. So C should be the answer. And here P is equals to Q. So this cannot be answered as there is no point of difference between A, B, C, D. Okay. Moving to question number 43. First, let us read the stem. Morphine and many of its homologs, when administered in medicinal doses, relieve pain and produce sleep. In poisonous doses, these analgesics are chiefly used for the relief of postoperative pain, cardiac pain, and pains of terminal cancer and in childbirth. Below 3 are narcotic analgesic. What is the molecular mass of the most acidic narcotic analgesic given above? Now, if we compare which one is most acidic, OH, OH, and OH. This is not at all acidic in the competition. These two are there. And amongst these two, if we compare, okay, this is a phenolic OH. This is an alcoholic OH. Alcoholic OH. And alcoholic versus phenolic, phenolic OH will be more acidic OH. And thus, here, the answer for question number 43 is molecular weight of morphine is our answer, which when you calculate is coming to 285. What is the molecular mass difference between heroin and codeine? I don't think इसमें किसी को भी problem होगी. Answer is 70. You directly have to calculate the molecular weights and give the answers. So no problem with that. Aspartame and allitame are two artificial sweeteners which shown below. Aspartame is 100 times as sweet as cane sugar, whereas allitame is 2000 times as sweet than cane sugar. Okay, if the absolute values of the net charge of the aspartame in this one at pH 2. So we have to find at pH 2 what is the absolute value of net charge of aspartame. Correct? So if I check at net charge of aspartame at pH 2, pH 2 is highly acidic. So acid part, no change. This will become +1. Amide will not be protonated. Okay. Is that clear? Amide is not in the race at pH 2. So at pH 2, charge is +1. But absolute value of charge, and a Z1, absolute is only 1. Now we go to pH 6. pH 6 is, I would say, slightly acidic pH. Okay, pH 6 is slightly acidic pH, which will rather function as isoelectric pH of this part, which will be isoelectric pH for this part. So this will become CO minus, this will become NH3 plus. So absolute value is 0 because -1 and +1. Total charge for Z2 will be 0. Okay, if total value of Z2 is 0, so हमसे तो पूछा है Z1 plus Z2, so answer is 1. Okay, this pH 6 is like a Zwitter, isoelectric pH for this part. If X is difference between molecular mass of allitame and aspartame, इन दोनों का molecular weight calculate करना है और आंसर निकालना है. ठीक. So what is the value of X. I don't think इसमें किसी को help की जरूरत होगी. So इसका answer whatever given 37. Just have to calculate the molecular weight and solve. Analyze the given data, match them for correct combination from column 1, column 2, and then answer the given questions. Okay, so BDE, it means form the radicals, right? You have to form the radicals, and stability of radical will be inversely related to bond dissociation energy of the bond. So A, if I take, we'll remove this. This is formed. This is formed. Similarly here. Now, highest percentages sp hybridized. So if I say this is going to be the most unstable radical, most unstable to highest BDE, so this should have the value for R. This one is a radical where second highest, so this will have the value of P, 111. Okay, so this is how we'll start approaching the question, that how to find the values for the different stabilities, and then we'll proceed that whichever is more stable should be having lesser value of BD. Right? So that is how we are taking the answer. So S is having, D is having 132. B is having the value for 111. Now comes A and C. Okay. Now between A and C, if I check, both are like this, in which, yes, it is a part of sp2 cloud, but comparatively, if I check, is a resonating cloud. So this having more resonance than this, right? So if I compare between these two, so C is having more resonance, so less energy, so Q, and A having less resonance, so S. Now let us see what is the question asked. Molecular mass of the compound which has second highest bond dissociation energy. So second highest was 111, benzene, correct? So for benzene, if I check, answer is 78. So for this, answer has to be 78. If X is the percentage of S character of carbon atom, which has highest CH bond dissociation energy, so that was acetylene, in that percentages, it has to be 50, right? 78 and 50 are the answers. Let's move to question number 49. Choose the correct options regarding the following molecules, given molecules. Okay, let us see. So first, basicity order is, out of these, the basicity order is R. Okay, it is a guanidine system. R has to be maximum. Q, amidine system. Till here, all good. Okay. So yes, we agree R and Q tak it is correct. S and then P. But S has a possibility of complete octet structure like this. P has, S does not. So this statement is wrong. Correct is R, Q, P, S. Why? Because P is having better resonance than S. In S, only carbons are giving, and you are having a structure where incomplete octet contributors are there. So R, Q, P, S. if I could give you the data, then pKa values are, okay, let us check for these structures. This one has a pKh of conjugate, pKAH of conjugate acids. Higher these values, higher the, I would say, basicity. Okay, so for R, it is 13.6. For S, it is 5.2, 12.4, and P has 7.1. The answer is RQPS. So this is not part of the answer. Conjugate acid of Q is less acidic than conjugate acid of R. Less acidic. Well, if it would have been less acidic, then its K will be less and pK will be higher, which is not so. So B is wrong. As Q is a poorer acid, right? I want to say basic strength is R greater than Q. Therefore, conjugate acid strength will be R less than Q. Right? So Q should be more acidic. यहाँ लिखा है less acidic, so this cannot be the answer. Conjugate acids of both P and S. P and S are aromatic. That is true. Because these non-delocalized lone pairs will be participants. That will certainly have no impact on aromaticity. So yes, that is true. Conjugate acid of S is more acidic than conjugate acid of P. Conjugate acid of S is more acidic than this. This is also true. Same as the way we discussed B1. Similarly, answer for this should be C and D. C and D. Okay, C and D will be the answers. Identify resonance structure for ion P. Okay, this is our ion and we have to identify resonating structure of this ion. We'll do, let us take this to the next page, which is the resonating structure. Now, if I compare the given structures in this one, there is 2 sigma bond gap. Well, that is also not a problem. But where did this bond go? This, if goes like this, then this should have been a positive charge, which is not there. So this cannot be the resonating structure. Moving to next. Here, they have shifted somehow this bond and O minus, which is also not a resonating structure. Plus, how come this thing came? Double bond N. If I say, okay, this went like this, then also it is not setting. So this is also not a resonating structure, right? Coming to here, everything seems to be same as this, but internally there is a complete benzene structure resonance is there. C should be the answer. D pe, if it go, that can D be the answer? If I check this, okay, this, oh, ये position is wrong. This bond यहाँ तक आए सही था. If this would have gone further, तो here bond होना चाहिए, not here. So this cannot be the answer, and so answer is only C. Choose the options where indicated electron pair is in sp2 hybridized orbital. Here, the hybridization of this is sp2, non-resonating lone pair. So yes, it is in sp2. Here, hybridization of this carbon is sp2, but the lone pair is in unhybridized p, is in unhybridized p orbital. So pair is in sp2. So A should be the answer. This is also non-resonating and 2 sigma 1 lone pair sp2. That is correct. Right? Same is the story with D. So answer should be for 51st. Answer should be A, C, and D. Right? Moving to 52. Which choose the correct option? Dipole moment of this structure is greater than this structure. Okay. Why dipole moment of this is greater? Because if we see from here, if I draw the structures, okay, there is cyanide, there is negative charge generated here. And if negative is generated here, this part is becoming aromatic. Okay, coming here. If I do somewhat like this, right? Now, this is not giving the correct polarity as required for aromaticity. And therefore, this is correct polarity. So we'll go yes, dipole moment of first is greater than second. Coming to this potential energy order. Potential energy order, it means it is high potential energy is less stability, is inverse of stability. More stable structure will have less potential energy. So this is more stable. So it should have less potential energy. Thus, this cannot be the answer. Okay. Resonance energy of furan is less than pyrrole because nitrogen being a better donor of lone pair than oxygen. So C. Okay, so C is correct. D, if I go by logic, right, it seems to be correct like this. That this has a higher dipole moment if I go by structure or if I go by simple resonating structure. But data wise, it appeared that dipole moment of tropolone is 3.71 dBi and of tropone is 4.17 dBi. So there is a possibility that could be a key change to A and C instead of ACD. Okay, so here there is a slight possibility if they go by data. If they go by logic, then there is no change. But if by data, then there is a possibility. Coming to number 53rd, choose the correct statement. M is the tautomeric structure of N. That is correct. As you can see, it is amide imidol tautomerism. M and N are functional groups. Yes, because tautomers are defined as the two functional groups which are in equilibrium. Deprotonation of M and N will give same ion. Deprotonation of M and N will give same ion. That is true. M and N are resonance structure. No, they are not resonating structures. So answer for this should be A, B, and C. That is correct. Choose the correct option. Polarization of sigma bond caused by polarization of adjacent sigma bond is known as inductive effect. True. Number of unpaired electrons remains same in resonance. Yes. When inductive and electromagnetic effect operates in opposite direction, then electromagnetic effect dominates. When last week we were doing this revision class, then I even shared NCRT and I think we found this line there. Hyperconjugation in propene involves sigma and pi star, correct? Because propene is CH2 double bond, CH single bond, CH2H. So what type of hyperconjugation? This type, in which if we see that this is the sigma and here when it is giving the lone pair, then here pi star is utilized. So bilkul D mein this answer seems to be correct. So 54 ka answer is A, B, C, D, all four options correct. Moving further, how many nuclei can share or bear the positive charge in the resonance hybrid of the given ion? So let us see. One already there. If it resonates like this, then plus here. If plus is here, then this will go and oxygen will have plus. Similarly, this side also plus and plus. So total, one side we have got 4. Now going here, 1. So plus 1. If plus is here, this lone pair can participate or this nitrogen lone pair can participate. And when they will participate, the charge will be positive on these donors, so plus 2. Right? So 4 plus 1, 5 and plus 2, 7. 7 should be the answer for 55. Okay? Is that absolutely clear? Please check. You should draw the hybrid and see wherever you are getting that positive charge on oxygen due to this plus. Okay, so answer is 7. When we go to 56, among the following, how many are aromatic? Let us see. This when polarized, like this structure, then this part is aromatic. 4n plus 2 equal to 6. 1, 2, 3, 4, 5, 6. So this is aromatic. Similarly, this can be aromatic. But this is anti-aromatic. Okay. This is aromatic. This is non-aromatic as there is sp3 carbon. This is non-planar and non-aromatic, and here minus, this minus is sp3, so non-aromatic. So let us come to this 1, 2, 3, 4, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 4n plus 2 equal to 18. N equal to 18 minus 2, 16 by 4, that is 4. So this is also aromatic. So how many are aromatic? 1, 2, 3, and 4. So answer for 56 should be 4. Among the following, how many are correct? Stability order. Now, if oxygen is the donor, then stability will be poor as compared to when nitrogen is the donor. So this is not the correct choice. Okay. Half-life. Half-life is inversely proportional to, directly proportional to stability. More stable ions will have higher half-life. So this is more stable. This should not be the answer. Okay. Coming here, carbocation stability, yes, percentage is less, carbocation is more stable. Carbanion percentage is more stable. Heat of combustion is inversely proportional to stability when they are isomeric. And yes, they are isomeric. So more stable is this one because more hyperconjugative. And then less and less. So answer seems to be correct. 6 CH bonds involved in hyperconjugation. 1, 2, 3, 4, 5, and 1 here, 6. So this is correct. So I think answer for this should be 4. And that brings us to the end of PTA. And in PTA, we found only one possible key change, 52nd. That to depend on the paper setter, how they will proceed by data or by uh, logic. So answer could be ACD or only AC. Is that okay? So moving to CTA. Let us start CTA. I think here is our CTA. One or more than one से start हो रहा है CTA. Let me open my hard copy also, in which I solved by hand. Okay, the correct statements about the following species is or are. One is more stable. Now, if you remember the tautomerism lecture, oxime was more stable than one, right? So nitroso was the unstable. Oximes are more stable than nitroso. 2 and 3 are diastereomers, yes, because they are GI. They are geometrical isomers, so they should be diastereomers. 3 is a tautomer of 1, that is also true. It is oxymino, and the original 1 is structure number 1 is nitroso. So there is nitroso oxymino tautomerism. Correct? So answer for this is coming B, C, and D. I hope there is no problem in this one. Choose the correct statement among the given options with the property given in bracket. 2 chlorine, 1 nitro, 1 fluorine. Right? So definitely this is correct. More acidic nature, more number of chlorine, number will dominate over power. And when number is same, then power is dominating. Thermal stability of this, no, that is wrong. Correct choice is meta is observed to be more thermally stable. Thermally stable. Meta is found to be more thermally stable. So this is not the correct. Moving to C. IUPAC of this compound is 5-ine 4-ol. No, that is not correct. It has to be smaller number for the functional group OH. So it should be, ene should be 5, ine should be 1, all should be 3, rest all correct. It should be hex 5-ene, 1-ine, 3 all. So these two can't be the answers. Okay. Energy difference between eclipsed and staggered conformation of ethane is 12.5 kilojoules per mole. That is true statement. So answer has to be A and D. Answer for this particular question is A and D, 40 number. Moving to question number 41. Which of the following is or are correct statements. Okay. Let me draw eclipsed conformation for all this. Let this be 1. Let this be 2. So 1 is eclipsed conformation I am drawing. Back bromine, CH3 and H. Front bromine, okay, H. I just drew the lines in a different way. So if I keep CH3 here, H here, bromine here. Now backside I oriented 180-degree opposite. So this is CH3, this is H. Similarly, for 2 I want to do. First, let me draw the front carbon, bromine, CH3H. Again, I want to bring bromine just in backside of bromine. Okay. If I want to bring bromine in the backside and behind CH3 it is H, and behind H there is CH3. If you see 1 and 2 are mirror images of each other, and certainly they will be non-superimposable mirror images of each other. So they are not conformational isomers. They are enantiomers. Okay, they are enantiomers. So this cannot be the correct answer. Here, in 3 mole of NaNH2, if I compare the order of acidity, first, then nitrophenol, then phenol, and then this is the fourth. So CO minus, O minus, and this is correct answer. This is what will behave as acidic when limited supply of NaNH2 is there. The number of possible esters of C4H8O2 is coming to. So we need to check. C4H8O2 esters, CH3, C4, H8. Let us check COOCH3. Now C3, 4, 5, 6, 7, 8, H8, C4, 1, 2, 3, O2. Correct. So one possible ester. Right. Second possible ester is CH3, COOCH2, CH3. That is also okay. Next is HCOO, CH2, CH2, CH3. So the statement is gone. I have got the third ester, maybe more, but I don't need to go further because, a correct name, incorrect name is 2. So this is untrue. This statement is not true. The number of stereoisomers possible for this compound is 4. That is true because this is pseudo-chiral, whose chirality depends on configuration of these two. Okay, let me call this as A, this chiral center as B, and this double bond as C. So for A, B, and C, if I say A is cis, B is cis, then C is cis, then B is not chiral. A is trans, cis, and C is trans, then not chiral. One cis, one trans, then yes. There will be 2 cases. Either this is R or this is S. So I will have cis R trans or cis S trans. So total 4 number of stereoisomers are possible for this 41st. And answer for 41st is thus B and D. Okay. Moving further. For the given compound, identify correct statements. Compound 1 is more basic when aromatic ring has methyl substituent. Yes, if I have methyl substituent, they will be more electron releasing, ultimately making it better plus I and more basic. More basic site in compound 2 is nitrogen atom. That is false because more basic will be oxygen atom. So this is not true. Correct statements we have to identify. Compound 3 becomes more basic when acetyl group is attached to the ring. Well, the acetyl group will not be part of resonance, but ultimately it is electron withdrawing, right? And if the group is electron withdrawing, then it cannot be acting as minus I. It cannot be making it as a better base. For being better base, I needed electron releaser, whereas here they are saying that what will be if acetyl group added, it is a minus I group. So no, this is not possible. Correct? This is not correct. That is what we want to say. The basicity of compounds follow the order. 4, yes, guanidine. 3 and 1. And then comes 2. 2 is going to be the worst. It is amide. 3 and 1, hybridization similar, it appears, but 3-member ring will be much poorer base. So D is answer. Answer for 42 is A and D. Okay. Moving to 36. Which of the following compound gives blood red color in Lysines test? So compound should have carbon, sulfur, and nitrogen. Then only it will form SCN. And then FeSCN whole thrice will be the blood red coloration. So A and C. Here, no nitrogen. So this cannot be the answer. Here, nitrogen will go very early on heating. So that cannot be the answer. So 43rd answer is A and C. Okay, answer is A and C only. Coming to 44, which of the following is or are correct? Enol form is more acidic than its keto form. True. Enolization will racemize any chiral center next to a carbonyl group. That should be false. So 44 can be a key change. Like why? Yes, it can. If any word was not there, can racemize chiral center next to a carbon group, then true. Any chiral center, no, because for example, if I have CH3, CC2H5 and PH, COCH3, then this will not be racemized as there is no alpha hydrogen. Tautomers can be isolated under specific conditions. Yes, ketonol tautomerism can exhibit kinetic and thermodynamic. Yes, because it is completely reversible. So it can exhibit kinetic and thermodynamics control. So 44 key change to ACD, that is correct. Okay. Coming to this, the diuretic cyclothiazide is used as a mixture of stereoisomer. It is capable of reducing or essentially eliminating rapid desensitization of the former structure. Its structure is given below. If number of chiral carbons 1, 2, 3 and 4. So chiral carbon count is 4. And sp2 atoms in a molecule. sp2 atoms primarily taken only carbon 1, 2, 3, 4, 5, 6, 7, 8. Then other atoms nitrogen 8, 9. Okay, 9, 10, 11, 11, 12, 13, 14, 14. This nitrogen is sp3. Huh? We have discussed in last week bonding class. When we did the resonance, I told you that aniline nitrogen is sp3. So we reached 14. Any more sp2 I am seeing? No. This I think is sp3 like H2SO4. Sulfur here is sp3. So sulfur should not be the answer. Right? So I think I have got 14. Let me recount 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So answer should be 18. If we take this 14, then the answer should be 18. Okay. Chlorine, I have to check that should it be considered or not. I don't think it should be considered. Usually, we'll check. How many optically active isomers can exist for the given compound? For the given compound number of active isomer, I'll take one chiral center, second. But this bridgehead should be taken as 1 unit. 1 unit. The answer is 2 raised to power 3, 8 for this. Okay, answer for this should be 2 raised to power 3, 8. Following are known for an organic compound. Its molecular formula is this C6H8BrCl. It is cyclic with all 6 carbon in the parent chain. Okay. Cl is present allylic on an allylic carbon. So 1, 2, this is chlorine ki presence. Bromine is present on an sp3 carbon at gamma position with respect to chlorine. So alpha, beta, gamma chlorine. So this is my bromine. Okay, this is my gamma carbon. So numbering, I have to check the numbering. What is the position of Cl in IUPAC name? 1, 2, 3. So answer is 3. What is the position of bromine in the IUPAC name of X? 3, 4, 5, 6. So this answer should be 5. So answer for 47 and 48 should be 3 and 5. Okay. This you should know that alpha is just next to chlorine. Next term, the polarity produced in a molecule as a result of higher electronegativity of one atom compared to other is termed as inductive transmission effect. These effects are of 2 types: plus I effect, minus I effect. How many of the following are correct statement with respect to transmission effect? It is permanent effect, correct. Mainly pi bonds, no. The inductive effect is not confined to polarization of one bond, but it is transmitted. Yes, yes. From source of atom, it goes away and gets relatively weaker, but it is certainly transmitted from source to further. 2 statements are correct. Inductive effect brings changes in physical properties such as dipolement, solubility, etc. And it also affects the rate. That is also correct. Carbon, oxygen, hydrogen bond is taken as a reference of inductive effect. 0 effect is assumed for this one. Correct? 1, 2, 3, 4. So answer for 49 should be 4. Okay. These are the correct choices. It is not the pi bond which is involved in this inductive effect. How many of the following represent correct descending order with respect to minus I? Cl, Bri, correct. Aldehyde and nitro, this is incorrect because answer should be NO2, CHO and then NR2. This is wrong. Same here also, Nr2 and NO2 is wrongly placed. Vinyl and phenyl, this is wrongly placed. pH is more than vinyl than hydrogen, so this is wrong, -I. This is correct. So correct choices makes the answer 2. How many of the following represent the correct descending order? Answer is 2. Coming to question number 51. The resonance structures are hypothetical and individually do not represent any real molecule. They contribute to the actual structure. Okay, the correct stability order of the following resonance structure is correct stability order. Nitrogen negative is more stable than this. So A is correct. Right? If I check here, this is more correct because OP plus, so this is wrong. If I check here, minus and oxygen lone pair repulsions will be high, so this cannot be stable. If I check these, then OP positive cannot be more stable. So this cannot be the answer. Answer is A. Okay. Identify incorrect. So wrong statement. CC bond length in benzene is longer than CC length due to resonance. This is correct. So this cannot be the answer. Z and Y. Then Z is less than Y. Here Z and Y are the bond lengths. This is also correct. This is true statement. This is true. Naphthalene has less magnitude of resonance energy per benzene ring than anthracene. That is untrue, false. Has more dipole moment than this. This is true. So whatever is true should not be the answer. Incorrect is C. Naphthalene has less resonance energy total as compared to anthracene. Okay, but if we are talking per resonance per benzene ring, then answer is naphthalene has more resonance energy per benzene ring, right? It has 5/2 bonds per benzene ring. Anthracene, if I go, it has 7/3 bonds per benzene ring, so it is less stable per ring. Coming to here, there are two mixtures of two compounds separated as below. Mixture 1 NaH compound 1 2 separated by differential extraction. Mixture 2 NHCO3 compound 3 compound 4 separated by differential extraction. Solubility is the criteria. Differential extraction matlab we have to use different solubility. Okay, one should be soluble, one should not be. Identify compound 1 and 2. 1 and 2 matlab aqueous NaOH. This cannot be because both are soluble. One should be soluble, one should be not. Okay, so this cannot be because both are insoluble. Ek second, we have to talk in, NaOH. Then to this should be, here it is not both. NaOH mein this is soluble. In NaOH, this is insoluble in NaOH. So C. Squaric acid, again both soluble. Ascorbic acid is structure of vitamin C. This could be a dispute because methanol is water soluble by itself. No need to do acid base just due to small hydrophobic. And this is insoluble. So not due to NaOH, but this being water soluble. So here you may expect a key change to B or C. Either B or C could be the answer. Though the better key is C. Because NaOH reaction is, if considered, then answer is C. 3 and 4. Reaction with NaHCO3. Now both are reacting with NaHCO3, not possible. Both reacting, not possible. Picric acid is pK less than 1, not possible. Both are reacting. Here, this is insoluble in NaHCO3. So this can be separated by NaHCO3. Okay. Moving to question number 55. Histamine, number of basic sites it can utilize when kept in a medium of pH 2. Answer is 2, 1, and second. This is acidic. How many of the following intermediate ions have at least one resonating structure in which all the atoms have their complete octet? Let us check this. So this should be the answer. Here not possible because there is 2 sigma bond distance. Here also 2 sigma distance, not possible. Here, yes, possible. So first and fourth. Here not possible. This plus cannot participate. It is cross conjugation. Yes, here possible because nitrogen can give complete octet. So this is answer. Here lone pair is not participation of resonance, so not possible. Okay, here it is meta positioned. This oxygen is meta position, so not possible. Here it is possible because this oxygen is para position. So answer is first, fourth, sixth, 7, 8, 9. Right? 1, 2, 3, 4. Yes, first, fourth, fifth, sixth, 7, 8, 9, and ninth. These 4. So answer is 4. Okay, this is correct. This is also a key change. 2, 3. Why? Penicillin will liberate CO2? Yes. Valium is not a barbiturate. Veronal is a barbiturate. Okay. Antagonist mimic the natural structure? False. Agonist mimic the natural messenger. Okay, not the antagonist. So this is also false. Cationic detergents have germicidal properties. Oh, sorry, receptors are crucial to body's communication. We forgot to read that. Yes, that is very true. So this should be the answer. Cationic detergents have germicidal, yes. Bacteria can degrade the detergents containing highly branched. No, that is wrong. So key change to 3 for question number 57, and that is our last question.